Hello all, welcome to Ambari Cloud YouTube channel. Today I will be reviewing in-place migration to convert Hive table to Iceberg. So we're going to discuss about in-place migration, pros and cons, and demo. So in-place migration. So let's say you have a Hive table, then you might have ORC or Parquet, right? Doesn't matter. And then what we'll be doing is we're gonna converting into in-place migration. When we do in-place migration, we're gonna convert your Hive table as Iceberg table, and then we will keep a backup table in a Hive format. So both backup table, which is in Hive format, and an Iceberg table, and both are connecting to the same file. Then after that, you're going to drop the Hive table. Then you will have your data is converted into an Iceberg format. Okay. Let's put it here. In Apache Iceberg, in-place migration refers to the process of converting an existing table into an Iceberg table without copying or moving the underlying data files, which is important, right? We're not moving any data files and we don't need extra storage, right? So instead of duplicating the data, in-place migration registers the existing data files into the Iceberg table metadata. So basically it converts behind the scene. We don't have to manual register and converts the Iceberg table Hive to Iceberg. But the process is simplified. You can do it in a different way, add files model. But here this makes you are converting Hive as it is in a simplified way. Okay. This allows the original table data to be managed and queried using Iceberg capabilities without physically moving the data. And another thing is you are keeping your Hive table as it is. So let's say you want to validate your Iceberg table after migration, then only you want to drop the table, right? So you can have both, but no duplicating of the data. That's the key. So here are the key points in place migration, data file registration. The data files from the original Hive table are registered in the Iceberg table metadata, and the actual data files remain in their original location, so they're not moving anywhere. No data duplication, since the files are not copied or moved. The processor is quick and does not require additional storage. So that is the key, right? So you don't need additional storage. But if you want to migrate from HDFS to Ozone, or you want to move into different locations, then you need additional storage. But in this in-place migration, you don't require any additional storage. And then as soon as when you do in-place migration, then Iceberg allows you to do time travel, schema evolution, ACID, and without changing any physical data. So it's just like a flipping Hive to Iceberg. Okay, so quick benefits, quick and storage efficient as it avoids duplicate data, and seamless transition. So the existing table, same database, same schema, right, and same table name is migrated to Iceberg. And then the downstream applications or upstream, any SQL pointing to this table, any tool pointing to this table, don't have to change anything. As we learn about Iceberg, about partitioning, hidden partition, all the stuff, there's no need to change our SQL, right? And definitely you will see a 10x performance. Limitations, of course, they work only on these file formats, Parquet, Avro, okay? While you are doing, if you are doing any insert updates, then sometimes migration takes time, right? It depends on the size of the table. So if your application inserting into the original Hive table, then that data may not be available, right? So the key here is when you are doing the migration, think about it as an event in your production system, right? And then make sure that no data is coming. However, right, if the data continuously coming, like a streaming application, then I don't recommend, or nobody recommends in-place migration. Then we have to do the different approach. That's what I will upload another video for that. So there right? So then you do partition by partition migration. Okay. So in-place migration is a powerful way to upgrade existing data infrastructure to leverage Iceberg capabilities with a minimal overhead, right? So what is the steps, right? So first thing is you need to make sure your Hive table can be converted into Iceberg, right? So for that we're going to use a snapshot approach. So basically what it does is it's create another Iceberg table pointing to same data with minimal data set. Then we can validate the Iceberg table, make sure that data is converted, all the data types are matched. If there is any issues, then we will find out here. So do not migrate your Hive table without testing, right? So that means you have to convert. First step is do a snapshot, right? So your Hive table points to another Iceberg table. Then once you're done, you validate the counts, not counts, validate the data set and other stuff. And then the migration successful, then what you do is drop this Iceberg table, then do the actual migration. So for that, you're going to use a migrate procedure. And then if you can just migrate, that means your Hive table is converted into Iceberg table. While you're migrating, you can also do rename table, right? And the important thing is the migration happening in the same metastore and same storage, of course, right? You're not, this is meant for same metastore and storage. If you want to do different metastore, different storage, this model doesn't work. We have to use a files approach. Then we recommend always do not drop the backup table while you are migrating, okay? Have it. And once you complete the migration, even though snapshot, you does all the testing, but even after migrate, make sure that you have a backup table. Once your migration done successful, all applications are able to connect, then drop your backup Hive table. Okay. So we're going to do a demo. So for this demo, I'm going to use Hive metastore, right? So you can download Hive 4.0. I'm using beta version. So what we'll do is I'm going to start my Hive Docker because I need a Hive database, and then I need to do some directory structure for my Hive metastore here. Then I'm going to execute my Spark shell. So here I'm using Spark shell instead of Spark SQL. I prefer Spark shell because you can use procedures easily. So if you look at here, the one video I have uploaded recently about catalogs. Here my catalog is a Spark catalog, and then I'm using Spark session catalog, and then of course using 1.50, and this is my thrift store. Right now my Spark ready. Then let's check what databases I have. Okay, well, we don't have any database, and maybe, yeah, this is fine. Okay, so I'm going to create a database called db4. Then let's check again what databases I have. I have a db4. Okay, just always practice this way. I have a db4 database, and then show tables, no tables, right? And then I'm going to again learn about how to drop, of course, just in case. You keep practicing, follow this step. And again, I'm showing in a notebook way, but again, we will do it in a Pythonic way, right? We can define your Python code. So here I'm creating an external table. This is my catalog. This is my database, my table name and location. Of course, external table need a location. Now let's go one more time, show tables. Okay, I have a table here. Then I'm going to insert data. Okay, then I'm going to select the data, and then I'm going to describe the table. So here my table is ORC, which is using Hive, Saturdays and other stuff, and this is my Hive table. Okay, and one more time, show tables, of course. Then here I want to show my table location, right? These are my 3 ORC file because I inserted 3 rows separately. It's not a single commit here. Okay. Now I'm going to test my Hive table to Iceberg migration. Okay. So here, the snapshot is my procedure and my Spark catalog, and my source table, my destination table. Okay. Any table we can do. So now I'm going to execute. So it's going to create in a Hive table, show tables again. Now if you look at here, I have my Hive table and also my Iceberg table, and both are pointing to the same. Now let's describe that table, right? Let's describe this my Hive table, Iceberg table. Look at here, it is pointing to the same, and then this is provider is Iceberg. Okay. Then let's do counts on my Iceberg table. Same count, right? Same, and the same as my Hive table. Maybe let's run one more time. Hive table. Okay, this is my Hive table. Both are same, right? So then what I'm going to do is I'm going to insert into my Hive table. Now I'm going to check the counts on my Hive table, right? Now I have extra rows, okay? Extra 3 rows. But I'm going to check the count on my Iceberg table because I can insert into my Hive table even after migration, right? Because this is a test, right? Here we are doing it. Okay. Now, then let's check the file structure, right? So now we have 6 files. Okay. Now it proved that we can able to migrate our Hive table to Iceberg. So this is the test you need to do. So for that, we're going to use a snapshot procedure, right? Once you've done your test, you can drop your V4, but I will keep it for now. Now let's get into the final migration. Now let's go to my Hive table one more time. Define. We know that this is a Hive table, right? Now I'm going to convert this table, and I'm going to rename. I'm not giving a different name. I'm going to convert the same Hive table as Iceberg table. So no need to change the name because I don't want my downstream or upstream application fail. So it's converted. Okay. And then let's do describe. Now remember here, when you describe Hive, right? See the difference? Now it's an Iceberg table, right? Previously, same people Hive, right? This is a Hive table, right? Now it's an Iceberg table. Now let's get the count on right? Let's count on the Hive table now one more time. Okay, there you go. My data is back. So it's but it's in Iceberg format. Okay, now let's do one more to show tables. Now if you see here, we have a backup table. Okay? Let's describe the backup table. This is an Iceberg table. Sorry, Hive table, right? So we have a Hive table and we have a Iceberg table, both pointing to the same file system. Now I have an Iceberg table ready. I'm going to insert my data. Okay, I'm going to do select on. Okay, now let's do select on backup table, right? So just for fun, okay, let's go to the backup table. It's old data, right? Because this table is still looking at. So now then, because our production table this is a guy, okay, it's an Iceberg format. Now let's run the file system. Now look at the file system here, right? In Iceberg, it always follows data and metadata structure. Okay. Now when we create the conversion, right? What we did is, the default is the Parquet format. So that means any new data inserted in Iceberg table is going to Parquet format because its default is Parquet. But if you look at here, originally our Hive table is in ORC, right? And also it's in a different directory, which is fine because we're getting the counts, right? When you do select star, now I got the data from these 3 Parquet files, 6 ORC files. But this is fine. But if you want to expose this table to a Snowflake or you want to use a X table conversion, we want everything in a Parquet format. right? So not only that, right? And we don't want multiple file formats and then multiple directories. It confuses to maintenance point of view. I mean, in a human maintenance point of view, Iceberg works, not a problem. So what we recommend as part of conversion, which is migration, right? The do follow this rewrites file. So let's look at all files belongs to the table, okay? And let's look at data files belongs to the table, okay? Both are same right now. All files, data files, right? And so you can look at the data files here, all files here, both are same. So what we will be going to do is we're going to rewrite it, right? So what we're going to do is we're going to unset the properties, okay? And then we're going to rewrite into some big file, right? Okay. So look at the 9 files are rewritten to one file, right? So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 files. And because we chose very big file. Now let's run again this all files and data files. Okay. So this is my data file because we rewrote into one big file here. So in the most recent snapshot is pointing to this file. Now let's run the all files also. They're still there, right? Right. Let's prove it one more time here. Yes, if you look at here, previously I have only 3. Now I have one more file. Then my ORC file as is, and then I have more snapshot. So why these files still there even after rewrite? It's a time travel, right? Because we want to do time travel, right? And even though we rewrote and then combine all these small files and these small files into one big file, right? But these are there for the time travel purpose. So generally when we do migrate, right? And then, after migration, there is no time travel yet, right? So we suggest, right, particularly in this Parquet and different directory structure, right, we're going to expire, right? Start with fresh time travel, right? So let's look at the snapshots, and then I'm ordered by descending, right? So this is my most recent snapshot. I don't want these two because we are not doing a time travel, right? So what we do is we take this time, okay? We're going to expire anything older than that. You can also do array using the snapshot IDs, but get the most recent time from this data frame and then get the max of it, and then you execute the expired snapshot. Now let's execute the expired snapshot. So we don't need a time travel, because immediately after the migration, rewrite the files, do time travel, expire it, then you will start with a 0 time travel, almost, yeah, so current time travel. So when you expire, look at this, all the old 9 files, right? And some of they are deleted. So let's go to one more. Now let's run this directory structure. Now look at this. Previously, I have these files, right? And then I have another, 9 files. They're all gone because we expect time travel. Now let's run these data files. After expire, I'm keeping only one snapshot. Okay. Then expire on all files. Both are same. So if you keep only one snapshot, most recent snapshot, then all files and data files are same. And then the old files are gone because we ran the expired snapshots. Okay. Then once you're done, and then again, next part of your migration, we're gonna rewrite manifest files, because you have too many manifest files, and then manifest files are, now if you look at data files are maybe in different directories, and your manifest file become bigger, so we need to readjust that. So we're going to rewrite the manifest file. Okay, so now look at these 3 manifest file become 1. Okay, and now let's run it again. Keep in mind those old manifest files are still there. Then again we're gonna write orphan files rewrite or remove orphan files and all other maintenance, right? You need to do that. But initially, I don't worry about it, right? So migration, rewrite data files, expire snapshot, and rewrite manifest file done, right? Because we don't want to run too many maintenances. Then part of later, right? If you look at my other YouTube about maintenance strategy, different maintenance approaches, then I will upload a maintenance strategy YouTube soon. But this is enough, right? So migrate, snapshot, test it, migrate, rewrite data files, right? And expire snapshot, rewrite manifest file. That's the part of your migration process. Both in place or other more add files approach. Okay. So this is how you're going to migrate. And then I suggest definitely start learning about using a Docker container Hive in our system. And that way you are working like in a production style. Okay. So thank you all. And if you have any questions, reach out to me. This is my information. Thank you. Bye now.